Good morning, students. So today we will discuss circular current loop and magnetic dipole. Right. So magnetic dipole, it is a product of that is magnetic dipole momentum. It is similar to that of the electric dipole, right? So now first chapter discuss ಮಾಡಿದ್ದು electric dipole. So electric dipole ಅಂದ್ರೆ two equal and opposite charges separated by a small distance. So two equal and opposite charges means if we take one as plus q and another one, we can take that one as minus q. So both charges having the same magnitude and these two charges are separated by a small distance 2a, right? So this we call as the electric dipole, and here we are getting the dipole momentum. So that is always in the direction from negative charge to positive charge. Electric dipole momentum we define with the letter P, that is equals to magnitude of either of the charge, so that is q into the distance between the two charges, that is 2a. So this gives what? Electric dipole moment, right? So these two also we discussed in our first chapter, right? So here we are going to discuss about the magnetic dipole. So ಯಾವುದು magnetic dipole ಆಗಿ behave ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ circular current loop which carries the current. So circular current loop behaves as a magnetic dipole. So that magnetic dipole is similar to that of the electric dipole, right? So in comparison with the magnetic dipole with the electric dipole and magnetic dipole moment with the electric dipole momentum, right? So consider a circular loop which carrying the current I. So idu now already one derive kuda madidvi, right? So circular current loop which is having the radius r. So on the axis somewhere at distance x from the center of the circular loop, we can find the magnetic field at this point P, right? So B is the magnetic field, right? So we derive the relation B is equals to mu naught I r square divided by 2 into r square plus x square whole to the power of 3 by 2, right? So ಇದನ್ನ ನಾವು derive ಮಾಡ್ಕೊಂಡಿದ್ವಿ so previous class ಅಲ್ಲಿ, right? So circular current loop ಇದೆ. So this is the circular current loop, right? So this circular current loop having the radius r, and we can find the magnitude r square plus x square whole power 3 by 2 the magnetic field, right? So x is very large compared to that of the radius of the coil, ತುಂಬಾ large irutte. So hence we can neglect the term r square in the denominator. So denominator aliro r square na ನಾವು ಏನು ಮಾಡಬಹುದು, neglect ಮಾಡ್ಕೋಬಹುದು. So we get the relation B is equals to mu naught I r square divided by 2. So here we have x square. So r square value ಏನಾಗುತ್ತೆ 0. So x square whole power 3 by 2. So square get cancel ಆಗುತ್ತೆ. So we getting x to the power of 3, right? So magnetic dipole momentum. So in the last class we discussed the M, that is equals to current into area, right? So idu ಏನು represent ಮಾಡುತ್ತೆ ಅಂದ್ರೆ magnetic dipole moment, right? So magnetic momentum, right? So magnetic moment is denoted by M, and that is equals to the current into area, right? So in the current elli flow aagta ide in the circular loop. So we want to take this as the area of the circular loop, right? So that is I into, so area of the circle is pi r square. So radius is capital R, so we can take here r square. So I into pi r square. So namge ee equation alli pi illa, so multiply and divide by pi. So numerator ಮತ್ತೆ denominator ಅಲ್ಲಿ pi ಇಂದ multiply ಮಾಡಿದ್ರೆ, so b is equals to mu naught I pi r square divided by 2 pi x cube, right? So this whole term I pi r square, we can write that as m. So P is equals to mu naught m divided by 2 pi x cube, right? So once again, we need to multiply and divide by 2 on numerator and denominator, right? So we getting magnetic field P is equals to mu naught by 4 pi into 2m divided by x cube, right? So this equation is similar to that of the electric dipole, right? So two charges minus q plus q separated by a small distance 2a. So at any point P, if we find the electric field on the axial line. So ಇಲ್ಲಿ ಕೂಡ axial line ಇದೆ. So ಇಲ್ಲಿ ಕೂಡ ನಾವು axial line ಅಂತಾನೆ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ here we can find the electric field E 2p vector divided by, so from the center of the dipole it is at a distance x ಅಥವಾ r ಅಂತ ತಗೊಂಡಿರೋದ್ರಿಂದ r, right? So ಇದನ್ನ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದು ಎಲೆಕ್ಟ್ರಿಕ್ dipole on axial line. So electric field on axial line of a dipole. So this is the magnetic field along the axial line, right? So comparing these two relations, right? So 1, 2. So comparing equation 1 and 2, right? So ಎರಡು equations na compare ಮಾಡಿದ್ರೆ, so in place of mu naught we can write 1 by epsilon naught, right? So observe ಮಾಡಿದ್ರೆ mu naught by 4 pi ಇದೆ. So r equation ಅಲ್ಲಿ 1 by epsilon naught ಇದೆ, right? So ಎರಡು ರಿಲೇಷನ್ ಏನಾಗುತ್ತೆ, mu naught ನ ನಾವು replace by 1 by epsilon naught ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ 1 divided by 4 pi epsilon naught. So ಇಲ್ಲಿ 2 ಇದೆ. Here also we getting the same 2, right? So in place of magnetic momentum m, we have the dipole moment p, right? So remaining x is the distance from the center of the circle. So here r is the distance from the center of the dipole, right? So from this we can prove that circular current loop as a magnetic dipole. So ಯಾವುದಾದ್ರೂ ಒಂದು ಸರ್ಕ್ಯುಲರ್ ಲೂಪ್ ಇತ್ತು ಅಂದ್ರೆ ಅದು ಯಾವ ತರ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ ಅಥವಾ ಯಾವ ತರ ಬಿಹೇವ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ಇಟ್ ಬಿಹೇವ್ಸ್ ಆಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡೈಪೋಲ್, ರೈಟ್? ಸೊ ಇದು ನಮಗೆ 3 ಮಾರ್ಕ್ಸ್ ಗೆ ಕೇಳಬಹುದು, ರೈಟ್? ಸೊ ಈ ಚಾಪ್ಟರ್ ಇಂದ ನಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ದಲೇ ಇರೋದ್ರಿಂದ ಥಿಯರಿ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್, ರೈಟ್? ಸೊ 3 ಮಾರ್ಕ್ಸ್ ಗೆ ಸರ್ಕ್ಯುಲರ್ ಕರೆಂಟ್ ಲೂಪ್ ಆಸ್ ಎ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಡೈಪೋಲ್ ಮೀನ್ಸ್ ಅಪ್ ಟು ಹಿಯರ್ ವಿ ನೀಡ್ ಟು ಡಿರೈವ್ ದ ರಿಲೇಷನ್. Comparison necessity ಇಲ್ಲ, so ಇಲ್ಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಪರ್ಪಸ್ ಗೆ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿರೋದು. ಸೊ ಇದು ನೀವು ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿದ್ರೆ ಅರ್ಥ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಬಂದು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಅದು ಎಲ್ಲಿಂದ ಬಂತು ಅನ್ನೋದು ನಿಮ್ಗೆ ಐಡಿಯಾ ಇರೋದಿಲ್ಲ, ರೈಟ್? So next topic is magnetic dipole moment in a revolving electron, right? So by using the Bohr's atomic model, so now already aduna study ಮಾಡಿರೋದ್ರಿಂದ Bohr's atomic model. So Bohr's atomic model consists of the nucleus of charge Ze. So it is positively charged nucleus and the electron is revolving around the nucleus, right? So of charge E. So it travels or it is moving with a constant speed v at a distance r from the center of the nucleus, right? So Bohr's atomic model namge ಏನು ಹೇಳುತ್ತೆ ಅಂದ್ರೆ, so hydrogen or hydrogen like atom, it consists of one nucleus of charge Ze and the electron is revolving around the nucleus with a constant speed v, right? So it is a distance r from the center of the nucleus, right? So as the electron is revolving, that means electron is moving, so electron move together, so with respect to time it constitutes the current, right? So as electron is moving means it is current is revolving, the current is flowing around mu-l, right? So mu-l is the magnetic dipole, right? So mu-l is the magnetic dipole momentum. So cross mark indicates what? The magnetic field is moving inside the board or inside the plane of the paper, right? So here we are going to find the mu-l relation, right? So I, that is equals to E divided by T. So this is again from the definition. So charge per unit time. So ಇಲ್ಲಿ charge ಅಂದ್ರೆ ಯಾವುದು ನಮಗೆ electron. So electron is revolving around the nucleus. So where T is the time period. Time taken to complete one revolution, so that we call as the time period, right? So as the electron is moving with the constant speed v, so v is equals to distance divided by time taken, right? So distance means to complete one revolution. So complete one revolution ನಾವು ಏನಂತ ಕರೀತೀವಿ time period. So one complete revolution means it indicates the circumference of the circle. So distance covered ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ನಮಗೆ circumference of the circle ಆಗುತ್ತೆ, right? So v is equals to 2 pi where r is the radius. 2 pi r is the circumference of the circle divided by time taken is t. So from this we can write t is equals to 2 pi r divided by v, right? So where v is the speed of the electron, right? So substitute here I is equals to, so idu elinda ಬಂತು from the definition in the chapter current electricity, I is equals to charge per unit time, right? So flow of charge per unit time ನಾವು ಏನಂತ ಕರೀತೀವಿ current. So here also the electron is moving, so V, so I is equals to EV divided by 2 pi, or calling this as first relation, right? So here we are going up to last we taken m, that is equals to I into A, right? So previous topic ವರೆಗೂ ನಾವು ತಗೊಂಡಿದ್ದು dipole moment now m. So previous topic ವರೆಗೂ ನಾವು ತಗೊಂಡಿದ್ದು dipole moment now m. So here the magnetic dipole moment we are taken that one as mu-l, right? So mu-l is the magnetic dipole moment, that is equals to current I into area. So current flow ಆಗ್ತಾ ಇದೆ, ಯಾವ ಏರಿಯಾದಲ್ಲಿ flow ಆಗ್ತಾ ಇದೆ, that is again it is a circular path. So current flowing in the circular path, so hence we are going to take the area as circle, right? So I into pi r square. So area of the circle is pi r square. So from equation 1 we have the value of current I, so substituting here, that is EV divided by 2 pi r into pi r square, right? So r square r, pi get cancelled, so we get the relation EVR divided by 2, right? So now multiply and divide by of the electron. So electron ge namge mass irutte, so numerator and denominator multiplied by the mass of the electron. So from this we can write E mv vr divided by 2 me, right? So up to now we discussed about the momentum. So first year allo study ಮಾಡಿರೋದು momentum p, that is equals to mass into velocity. So mass into velocity we define that one as the momentum. So here we having mass into velocity into path, right? So that we call as orbital angular momentum. So ಇದನ್ನು ಕೂಡ ನಾವು ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. So that is denoted by L, so that is mvr. So mass of the object, velocity and radius. So circular path ಅಲ್ಲಿ ಅದು rotate ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ ಅದನ್ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ orbital angular momentum. So here this one is the linear momentum. So linear momentum means it is moving in a straight path. So here orbital means it is moving in a circular path, right? So here by taking the relation MVR, so that is replaced by L, right? So E divided by 2ME into L, right? So where L is the orbital angular momentum. So on that value is L is equals to MEVR, right? So adu kuda ನಾವು ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿದೀವಿ, right? So system of particles chapter ಅಲ್ಲಿ ಇದು ಬರುತ್ತೆ, orbital angular momentum ಜೊತೆಗೆ linear momentum, right? So this ratio mu L by L, that is equals to E divided by 2ME. So when E is the charge of the electron, ME is the mass of the electron. So idudu constant value ide, idudu constant value ide. So substitute ಮಾಡಿ simplify ಮಾಡಿದ್ರೆ we get the value 8.8 into 10 to the power of 10 coulomb per kg, right? So this ratio we call as gyrometric ratio. So this ratio we call as gyrometric ratio, mu L by L, that is magnetic dipole momentum to the orbital angular momentum. So that ratio is E by 2MV, where E is the charge of the electron and ME is the mass of the electron, right? So again from the Bohr's atom model, so orbital angular momentum L, that is equals to NH divided by 2 pi, right? So idu ನಾವು maximum chemistry ಎಲ್ಲ ಸ್ಟಡಿ ಮಾಡಿರ್ತೀರಾ, right? So Bohr's atom model ಅಲ್ಲಿ angular momentum L we taken the value as NH divided by 2 pi. So substituting here, so we getting the value mu L, that is equals to E divided by 2ME into NH divided by 2 pi, where H is the Planck's constant and this value we call as Bohr magneton. So RHS alira terms complete ಆಗಿ ಎಲ್ಲ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂ ಇದೆ. E is the charge of the electron, N is the numbers, that is the integers, so ranging from 1 2 3, and H is the Planck's constant, M is the mass of the electron, and again pi is constant. So in these two values the substitute ಮಾಡಿ simplify ಮಾಡಿದ್ರೆ we get the value 9.27 into 10 to the power of minus 24 ampere meter square, right? So that value we call as the Bohr magneton, right? So this is the final expression. Also we call this one as spin angular momentum. So ಇದನ್ನ ನಾವು ಏನಂತ ಕರ್ಕೊಂತೀವಿ, spin angular momentum ಅಂತ ಕರೀತೀವಿ ಅಥವಾ Bohr magneton ಅಂತಾನೂ represent ಮಾಡ್ಕೊಂತೀವಿ, right? So derivation ಅಲ್ಲಿ ಕೇಳಿದ್ರೆ up to here we can stop the relation, right? So in case they ask for the Bohr magneton means again we need to substitute L value, that is NH by 2 pi. So substituting here we getting the Bohr magneton, right? So ಇಲ್ಲಿವರೆಗೂ ಕೇಳಿದ್ರೆ gyrometric ratio ಕೇಳಿದ್ರೆ up to here. So L ನ LHS shift ಮಾಡಿದ್ರೆ mu L by L, and that is equals to E by 2ME. So ಇದು ಕೂಡ constant value. So that value is 8.8 into 10 to the power of 10 coulomb per kg, right? So here, so all these values are again constant. So substitute ಮಾಡಿ simplify ಮಾಡಿದ್ರೆ this value ಬರುತ್ತೆ, right? So this is about the revolving electron. So this is applicable for hydrogen or hydrogen-like atom. That means helium, deuterium. So adu elladukku apply agutte, right? So these are the concepts based on 3 marks. So 3 marks ge related concepts in this to know. So first start ಏನಿಂದ ಆಗುತ್ತೆ ಅಂದ್ರೆ electron revolve ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ, so it takes some time, so electron is also moving, so that we can constitute as current, right? So current flow ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ it produces the magnetic field, so that we taken as the magnetic dipole moment, that is mu L, right? So again by basic relation. So velocity in the, we can find the time. So substituting here that again by taken here the relation mu L. So previous topics allela ನಾವು m ಅಂತ ತಗೊಂಡಿದ್ವಿ, but electron concept ಬಂದಿರೋದ್ರಿಂದ we take that one as mu L, right? And the last topic of this chapter, moving coil galvanometer. Right. So what is galvanometer? Galvanometer is a device which is used to detect the flow of current. So ಯಾವುದಾದ್ರೂ ಒಂದು ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆನೋ ಇಲ್ವೋ ಅನ್ನೋದನ್ನ ಚೆಕ್ ಮಾಡೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳೋ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ಅಥವಾ ಡಿವೈಸ್ ನ ನಾವೇನಂತ ಕರಿತೀವಿ, galvanometer, right? So here moving coil galvanometer means coil is moving or rotating. So name given as moving coil galvanometer, or simply we call that one as the galvanometer, right? So the construction of the galvanometer is, it consists of a coil with n number of turns, right? So ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ಸೊ ಯಾವ ಟಾಪಿಕ್ ಮಿಸ್ ಮಾಡಿದ್ರು ಈ ಟಾಪಿಕ್ ಮೇಲಂತೂ 3 marks ಗೆ ಅಥವಾ 2 marks ಗೆ ಕ್ವೆಶ್ಚನ್ ಇದ್ದೇ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ದಿಸ್ ಇಸ್ ದ ಕಾಯಿಲ್. So centrally it is pivoted, right? So moving coil galvanometer consists of a coil with n number of turns and it is freely rotate in the radial magnetic field. So ಇದು ಫ್ರೀ ಆಗಿ rotate ಆಗುತ್ತೆ in the magnetic field. So that magnetic field is provided by the permanent magnet. So galvanometer device ಇದೆ. So ನೀವು ಲ್ಯಾಬ್ ಅಲ್ಲಿ ಬಂದಾಗ ಅದು ಯೂಸ್ ಮಾಡೋದ್ರಿಂದ ಅಲ್ಲಿ ಕ್ಲಿಯರ್ ಐಡಿಯಾ ಬರುತ್ತೆ. So inside the galvanometer ಈ ತರ ಇರುತ್ತೆ. So these are the permanent magnets, right? So north pole and south pole, right? So these provide the radial magnetic field. So electric field or magnetic field lines we will discuss in our next chapter. So next chapter ali magnetic field lines ಬಗ್ಗೆ discuss ಮಾಡ್ತೀವಿ. So there we are going to discuss about the radial magnetic field, right? So these are the magnetic field B. So B represents what? The magnetic field, right? Next, so this coil is mounted on the cylindrical soft iron core. So this one is the soft iron core. So this is in cylindrical shape. So cylindrical shape means, so idu cylindrical shape alli irutte. What the help of this soft iron core is, it increases the strength of the magnetic field. So it increases the strength of the magnetic field. So magnetic field the strength na increase ಮಾಡೋದು ಯಾವುದು increase ಮಾಡುತ್ತೆ? Soft iron core, right? So one pointer is attached to the soft iron core. So this one is the pointer, right? So it is attached to the measuring scale. So this is the scale, right? Core. So this one is the spring SP, right? So SP indicates what? The spring, right? So this is the construction of the moving coil galvanometer. So galvanometer alli ಏನು ಇರುತ್ತೆ ಅಂದ್ರೆ permanent magnets ಇರುತ್ತೆ. So soft iron core which is mounted by the coil which having the n turns and the spring is attached to the soft iron core and to that of the coil, right? So one pointer is attached to the soft iron core and that one is displayed on the scale, right? So this is the construction of the moving coil galvanometer, right? So coil is that. So as the current which is flowing through the coil, so ಯಾವ್ದಾದ್ರು ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ನಾವು ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ನ ಕನೆಕ್ಟ್ ಮಾಡಿದ ತಕ್ಷಣ ಆ ಸರ್ಕ್ಯೂಟ್ ಗೆ ಕರೆಂಟ್ ಸಪ್ಲೈ ಮಾಡಿದ್ರೆ, so that current is flowing through this coil, right? So as current is flowing through the coil and it has the magnetic field, so magnetic field in the net force ಏನಾಗುತ್ತೆ zero ಆಗುತ್ತೆ, so hence we are getting the torque. So last class ಅಲ್ಲಿ ನಾವು ಡಿಫೈನ್ ಮಾಡ್ಕೊಂಡಿದ್ವಿ torque tau, that is equals to BI A sin theta. So this is the relation which we get in the last class, right? So torque, so here also coil is that, coil will define tau is equals to, so where n is the number of coils, so current ಎಷ್ಟು coil ಅಲ್ಲಿ flow ಆಗ್ತಾ ಇದೆ, n number of turns ಅಲ್ಲಿ current flow ಆಗ್ತಿರೋದ್ರಿಂದ, so that we can take NI B A, right? So here sin theta value is equals to 1 because the reason is radial magnetic field. So radial magnetic field irodrinda sin theta value enagutte 1 agutte, so 1 into Ni BA, right? So this is the equation 1, the torque which is experienced by the coil, right? So this coil is connected to the spring and it is mounted onto the cylindrical core, right? So ee spring na connect madilla andre ee coil enagutte continuous rotate agutte, so pointer kuda enagutte 360 degree continuous rotate agutte, right? So as the coil is connected with the spring, so spring connect agirodrinda it has a maximum turns aste, so solpa turn agutte, that is because due to the spring, right? So spring is connected to counterbalance this torque, right? So why we connected the spring? So spring is connected to counterbalance, that means to balance the torque. So torque add ಮಾಡ್ತಿರೋದನ್ನ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡೋದಕ್ಕೋಸ್ಕರ ನಾವು ಏನು ಕನೆಕ್ಟ್ ಮಾಡಿದ್ವಿ, ಸ್ಪ್ರಿಂಗ್. ಸೊ ಸ್ಪ್ರಿಂಗ್ ಅಲ್ಲಿ ಕೂಡ ನಮಗೆ ರಿವರ್ಸ್ torque ಸಿಗುತ್ತೆ, so that torque that is equals to k into pi, right? So where k is constant, so that constant we call as torsional constant, right? So calling this as the second equation. So this is the torque which is produced on the coil and this is the torque which is produced on the spring. So this torque balances the torque which is produced in the coil, right? So ಎರಡು ಕಡೆ torque same ಇರೋದ್ರಿಂದ we can equate the RHS value, so that k pi that is equals to Ni BK, right? So from this deflection phi that is equals to N BA by K into depends on current I. N ಅನ್ನೋದು number of turns, so coil ಅಲ್ಲಿ ನಾವು complete galvanometer ಅಲ್ಲಿ 100 turns ಇರುತ್ತೆ, so current ಗೆ ಮತ್ತೆ number of turns ಗೆ independent ಆಗಿರುತ್ತೆ, right? So ಒಂದ್ಸಲ ಅದರಲ್ಲಿ 100 turns ನ ಫಿಕ್ಸ್ ಮಾಡಿದ್ರೆ n ಏನಾಗುತ್ತೆ ನಮಗೆ ಕಾನ್ಸ್ಟೆಂಟ್, ಸೊ ಮ್ಯಾಗ್ನೆಟ್ ಇಂದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಬರ್ತಾ ಇರೋದು ಕೂಡ ಏನಿರುತ್ತೆ ವ್ಯಾಲ್ಯೂ ಕಾನ್ಸ್ಟೆಂಟ್, ಅಂಡ್ ಏರಿಯಾ ಆಫ್ ದ ಲೂಪ್ ಅದು ಕೂಡ ಏನಿರುತ್ತೆ ನಮಗೆ ಕಾನ್ಸ್ಟೆಂಟ್, ಅಂಡ್ ಟಾರ್ಷನಲ್ ಕೂಡ ಕಾನ್ಸ್ಟೆಂಟ್ ಇರುತ್ತೆ. ಸೊ ಆಲ್ ದೀಸ್ ಆರ್ ಕಾನ್ಸ್ಟೆಂಟ್, ಸೊ pi is directly relates with I, right? So current increase ಅಂದ್ರೆ ಡಿಫ್ಲೆಕ್ಷನ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಸೊ ಡಿಫ್ಲೆಕ್ಷನ್ ಜಾಸ್ತಿ ಆದ್ರೆ ನಮಗೆ ಪಾಯಿಂಟರ್ ಅಲ್ಲಿ ರೀಡಿಂಗ್ಸ್ ನ ತೋರಿಸ್ತಾ ಹೋಗುತ್ತೆ, ರೈಟ್? ಸೊ ಕರೆಂಟ್ ಕಮ್ಮಿ ಇತ್ತು ಅಂದ್ರೆ ಕಡಿಮೆ ಡಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸುತ್ತೆ, ಕರೆಂಟ್ ಜಾಸ್ತಿ ಆಯ್ತು ಅಂದ್ರೆ ಜಾಸ್ತಿ ಡಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸುತ್ತೆ, ರೈಟ್? ಸೊ ದಿಸ್ ಇಸ್ ದ ವರ್ಕಿಂಗ್ ಆಫ್ ದ ಮೂವಿಂಗ್ ಕಾಯಿಲ್ galvanometer, right? So this is also for 3 marks, right? So simple is that construction, working. So working is based on the torque. So torque ಮೇಲೆ ಮೂವಿಂಗ್ ಕಾಯಿಲ್ galvanometer ವರ್ಕ್ ಆಗುತ್ತೆ, right? So next galvanometer the application ಏನು ಅಂದ್ರೆ it measures it detects the current, it will not measures the current, right? So galvanometer measure ಗೆ ಮತ್ತೆ detect ಗೆ ಎರಡರಲ್ಲೂ ತುಂಬಾ ಡಿಫರೆನ್ಸ್ ಇದೆ. ಮೆಜರ್ ಅಂದ್ರೆ it gives the reading, so ಎಷ್ಟು ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನ ಮೆಜರ್ ಮಾಡೋದಕ್ಕೆ ಮೆಜರ್ಮೆಂಟ್ ಅಂತೀವಿ. So it gives the deflection readings ಅಷ್ಟೇ, so ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಿದೆನೋ ಇಲ್ವೋ ಅಂತ ಟೆಸ್ಟ್ ಮಾಡೋದಕ್ಕೆ ಮಾತ್ರ ನಾವು ಏನು ಯೂಸ್ ಮಾಡ್ತಿದ್ವಿ, galvanometer, right? So galvanometer cannot be used as ammeter. So what is ammeter? Ammeter is a device which is used to measure the flow of current. So ಎಷ್ಟು current flow ಆಗ್ತಾ ಇದೆ ನಾವು readings ನ ಹೇಳೋದಕ್ಕೆ ನಾವು ಏನು ಯೂಸ್ ಮಾಡ್ಕೊಂತೀವಿ? Ammeter. So there is a difference in galvanometer and ammeter. So galvanometer ಅಲ್ಲಿ it shows only the flow of current is there or not ಅಷ್ಟೇ. So current flow ಆಗ್ತಾ ಇದೆನಾ ಇಲ್ವಾ ಅನ್ನೋದನ್ನ ಚೆಕ್ ಮಾಡೋದಕ್ಕೆ ಮೀಟರ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Ammeter ಅಲ್ಲಿ we can get the reading. So ಎಷ್ಟು current flow ಆಗ್ತಾ ಇದೆ 5 amperes 10 amperes. So that gives what the ammeter. So ಎಷ್ಟು current flow ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನ ಹೇಳೋದು ammeter. So current flow ಆಗ್ತಿದೆನಾ ಇಲ್ವಾ ಅಂತ ಹೇಳೋದು galvanometer, right? So here galvanometer cannot be used as ammeter. So why? Because we have the two reasons. So galvanometer is a very sensitive device, right? So it shows the deflection even for a small order of the current, that is of the micro amperes. So ಸ್ವಲ್ಪ current, that is the current is of the order 10 to the power of minus 6 amperes ಅಲ್ಲಿ ಇದ್ರೂ ಕೂಡ it shows the deflections, right? So hence we call that one as galvanometer is a very sensitive device, right? So ಇದು ತುಂಬಾ sensitive ಆಗಿರೋದ್ರಿಂದ so ಸ್ವಲ್ಪ current flow ಆಯ್ತು ಅಂದ್ರೂ ಕೂಡ it shows the deflection, right? So that's why we are not going to use galvanometer as ammeter. So galvanometer na now current reading ಮಾಡೋದಕ್ಕೆ ಏನು ತಗೊಳ್ಳೋದಿಲ್ಲ ಅಂದ್ರೆ this is one reason, right? So the another reason is ನಾವು ಯಾವುದಾದರೂ ಒಂದು ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ so that circuit we need to connect the ammeter in series. So series ಅಲ್ಲಿ connect ಮಾಡಿದ್ರೆ we can get the current flowing in the circuit, right? So as the galvanometer we connected in series, so this galvanometer has a resistance. So that resistance is very large, right? So ಈ resistance ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ current values ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ ನಮಗೆ ವೇರಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So ಇಲ್ಲಿ ನಾವು ಫ್ಲೋ ಆಗ್ತಾ ಇರೋದು some 5 amperes current ಇತ್ತು ಅಂದ್ರೆ ಇಲ್ಲಿ resistance ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ current, that means voltage drop ಆಗುತ್ತೆ. So ಇಲ್ಲಿ ಬರೋ current ಏನಾಗುತ್ತೆ ಈ 5 amperes ಗಿನ less ಇರುತ್ತೆ, right? So hence we are not going to use the galvanometer in place of ammeter, right? So that is because of the two reasons. One is galvanometer is very sensitive device and it shows deflection even for the micro, that is of the order microamperes. So that is 10 to the power of minus 6 ಅಲ್ಲಿ ಇದ್ರೂ ಕೂಡ that means very very less value ಅಲ್ಲಿ current flow ಆದ್ರೂ ಕೂಡ ನಮಗೆ ಏನು ತೋರಿಸುತ್ತೆ galvanometer ಅಲ್ಲಿ deflection ತೋರಿಸುತ್ತೆ, right? So the second reason is galvanometer has a large resistance because here we have wounding the number of turns. So 100 turns na ನಾವು coil na wound ಮಾಡಿದೀವಿ ಅಂದ್ರೆ again coil is a conductor, so it has a resistance. So hence the coil has a large resistance. So current flow agida as it is in the series, so here the voltage is dropping, right? So voltage drop ಆಗೋದ್ರಿಂದ ನಮಗೆ output current ಅಲ್ಲಿ deflection ಏನಾಗುತ್ತೆ vary ಆಗುತ್ತೆ. So from these two reasons we are not going to use the galvanometer in place of the ammeter, right? So this is about the moving coil galvanometer, right? So now ಈ ಇರೋ ಟಾಪಿಕ್ಸ್ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ. ಸೊ ಯಾವುದಾದ್ರು ಒಂದು ಇಯರ್ ಅಲ್ಲಿ ಕೇಳ್ತಾನೆ ಇರ್ತಾರೆ, ರೈಟ್? ಸೊ ದಟ್ ಫಸ್ಟ್ ಒನ್ ಈಸ್ galvanometer as ammeter. So we can convert galvanometer into ammeter, right? So this is a galvanometer which has the resistance Rg. So in the resistance internal alli irutte, but we are expressing that in the outside, right? So this is the galvanometer and it has the resistance Rg. Rg is the resistance of the galvanometer. So we can convert this galvanometer into ammeter, that is by connecting one small resistance that we call as shunt resistance or yes, which is connected in parallel to the galvanometer. So ಒಂದು galvanometer ಗೆ ನಾವು small resistance ಅಥವಾ ಅದನ್ನ shunt resistance ಅಂತ ಕರಿತೀವಿ. That's why we taken small rs. So small r indicates what? Less resistance. S indicates what? Shunt resistance. So ಯಾವುದೋ ಒಂದು ಸಣ್ಣ ವೈರ್ ನ galvanometer ಗೆ parallel ಆಗಿ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ so this combination acts as an ammeter, right? So ಇದು 3 marks ಗೆ ತುಂಬಾ ಸಲ ಕೇಳಿರೋದು ಕೂಡ, right? So conversion of galvanometer into ammeter, right? So tumma important for 3 marks, right? So where I is the current flowing through the galvanometer. So galvanometer alli flow agta iro current na Ig. So again at this junction current divides. Ig is the current flowing through the galvanometer and the remaining current I minus Ig flowing through the shunt resistance, right? So Rs is the shunt resistance. So ಇದಕ್ಕೆ relation ಇದೆ, right? So again by using the Ohm's law, so potential across the combination, parallel combination ಅಲ್ಲಿ potential ಎರಡರಲ್ಲೂ ಕೂಡ ಏನಿರುತ್ತೆ ನಮಗೆ ಸೇಮ್ ಇರುತ್ತೆ, right? So potential across the galvanometer is equals to the potential across the shunt resistance. So from that we can write Ig into Rg, that is equals to I minus Ig into Rs. So from this we are going to find the value of Rs, right? So Rs is equals to Ig into Rg divided by I minus Ig. So ಈ ಸ್ಟೆಪ್, ಸೊ ಈ ಡಯಾಗ್ರಾಮ್ ಜೊತೆಗೆ ಈ 2 ಸ್ಟೆಪ್ಸ್ ಬರಿಬೇಕು. ಸೊ ಅದರಲ್ಲಿ ಒಂದು ಸೆಂಟೆನ್ಸ್ ನ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. ಸ್ಮಾಲ್ ಶಂಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇಸ್ ಕನೆಕ್ಟೆಡ್ ಇನ್ ಪ್ಯಾರಲಲ್ ವಿತ್ ದ galvanometer, right? So ಇಷ್ಟು ಬರೆದು ಈ ಸ್ಟೆಪ್ಸ್ ಬರೆದ್ರೆ we can convert the galvanometer into the ammeter. So where Rs is the shunt resistance, Ig is the current flowing through the galvanometer and I is the total current flowing in the circle, right? So here one more term we are getting, that is current sensitivity. So what is current sensitivity? So that is deflections per unit current. So deflections per unit current na navenanta karitivi current sensitivity, right? So last relation, moving coil galvanometer pi is equals to NBA by K into I. So deflections, that is pi and the current is I, right? So that is pi divided by I, that is equals to NBA by K, right? So this ratio we call as current sensitivity, right? So deflections per unit time, so that we are going to measure in ammeter, right? So next, galvanometer as voltmeter. So voltmeter is a device which is used to measure the voltage and ammeter is a device which is used to measure the current. Used to measure the current. So here voltmeter is a device which is used to measure the voltage. So again, first we need to consider the galvanometer, right? So G, and it has the resistance Rg, right? So this is the galvanometer. To this galvanometer we are going to connect the high resistance, that is large resistance, in series with the galvanometer. So we can take that as R, where R is the resistance. So capital R represents what? The large resistance or high resistance. So high resistance is connected in series with the galvanometer. So this total combination gives what? So this total combination gives the voltmeter, right? So here I is the current or Ig is the current flowing through the galvanometer, right? So again from the Ohm's law, V is equals to IR. So V is equals to Ig into two resistances are in series, so we can add Rg plus R, right? So from this we are going to find the value of R. So shifting to the LHS, V divided by Ig, that is equals to Rg plus R. So R is equals to V by Ig minus Rg. So this is the conversion of galvanometer into voltmeter, right? So 3 marks here, ಎರಡರಲ್ಲಿ ಯಾವ್ದಾದ್ರು ಒಂದು ಇದ್ದೇ ಇರುತ್ತೆ, right? So galvanometer into ammeter means, so small resistance is connected in parallel with the galvanometer. So voltmeter ge high resistance is connected in series with the galvanometer, right? So two relations. So again, ಇಲ್ಲಿ current sensitivity ಬಂದ್ರೆ ಇಲ್ಲಿ ಬಂದ್ಬಿಟ್ಟು voltage sensitivity. So again, voltage sensitivity is deflections per unit voltage. So deflections per unit voltage ನಾವೇನಂತ ಕರಿತೀವಿ voltage sensitivity. So from again this relation pi is equals to n VA by K into I. So pi by V ಬರಬೇಕು. So in this relation ನಮಗೆ V ಇಲ್ಲ. So multiply and divide whole equation by V, right? So here pi by V is equals to n VA by K into I by V. So again V is equals to IR. So I by V that is equals to 1 by R. Right? So pi by V is equals to NVA by K into 1 by R. So this R is the resistance what we connected in series with the galvanometer. Right? So ಇದು ನಮಗೆ voltage sensitivity. So current sensitivity ಗೆ direct ಆಗಿ ಬರುತ್ತೆ. I ನ electric shift ಮಾಡಿದ್ರೆ we get the ratio. So here we don't have any V values on multiply and divided by V, right? So that we get the voltage sensitivity. So this is all about the moving charges and magnetism, right? So this too about this chapter. So next chapter we will start from tomorrow. Thank you. Any doubts?